The following presentation is brought to you by Discovery Education, leading the world of digital and video learning. Discovery Education, connect to a world of learning. Between the orbits of Mars and Jupiter is a region called the asteroid belt. This is a region filled with space debris. Possibly a planet was supposed to occupy this orbit, but it never completely formed, or maybe it collided with something and exploded into thousands of pieces. Scientists believe that this belt formed at the same time the solar system and its planets were forming. That is, around 4.5 billion years ago. As the asteroids orbit the Sun, they travel in the same direction as the planets. It takes the asteroids 3 to 6 Earth years to go around the Sun. Asteroids range tremendously in size, from fragments the size of a grain of sand to pieces as large as the state of Texas. An asteroid may be pulled out of its orbit by the gravitational pull of a planet. Scientists think that that's what happened with Mars and its 2 moons. The moons were originally asteroids, which were drawn into Mars's orbit by the planet's gravitational pull. Asteroids may also collide with a planet or moon. These collisions form impact craters. Because the outer planet Jupiter is so large and has such a strong gravitational pull, it helps keep most asteroids in their orbits around the Sun. In this way, Jupiter protects planets closer to the Sun from constant asteroid collisions. A meteoroid is a piece of stony or metallic space debris. Some come from the asteroid belt and some from other orbits. If the debris comes into contact with the Earth's atmosphere, it heats up and glows. We see it as a streak of light in the sky and refer to it as a meteor. It usually takes only a few seconds for it to burn up in the atmosphere. People often refer to these as shooting stars or falling stars. But they have nothing to do with the stars. Stars don't fall, and they are much too far away to enter Earth's atmosphere. What we are viewing is the effect of something traveling very fast, making contact with our atmosphere. It heats up, glows, and burns up. The atmosphere protects our planet from the space debris that rains down on Earth. If a piece of the meteor manages to reach the surface of the planet, it is called a meteorite. Most meteorites land in the ocean, but sometimes they strike land. This is the Barringer meteorite crater near Winslow, Arizona. It was made about 50,000 years ago by a 300,000-ton meteorite. This garage and Model T Ford were hit by a softball-sized meteorite. The meteorite went through the wood of the garage, through the metal roof of the car, through the car seat, and the metal floor. Finally, it came to rest on the muffler. Even though meteorites strike the Earth each year, the chance of one coming down anywhere near you is highly unlikely. Past the asteroid belt are the outer planets of our solar system, known as the gas giants. Making a really large-scale model of the solar system can give us an idea of the huge distances between the planets, especially between the inner and outer planets, and between the outer planets themselves. Every illustration you have ever seen of the solar system on a poster or in a book has been misleading. That's because the distances are so vast that it is impossible to show the planets in a correct configuration. Even the use of long sheets of butcher paper wouldn't help. In our model, we will use the scale of 1 inch equaling 1,000,000 miles. 1,000,000 miles is 125 times the distance around the Earth. To construct our scale model, we will need to go outside to find an open area that's large enough. At one end of this field is the Sun. Then, 36 inches away is the planet Mercury, which in reality is about 36 million miles away. Next comes Venus. In our model, it will be about 67 inches away from the Sun. Then comes the Earth. Our planet is positioned about 93 inches away from our make-believe Sun. Remember, that's really a distance of 93 million miles. Now we put the fourth planet, Mars, into its position at a distance of 141 inches. Then comes Jupiter, the first of the outer planets. It is 483 million miles from the Sun. So in our model, we put it 483 inches away. Saturn is almost twice the distance from the Sun as Jupiter. Its position in our scale model puts it 888 inches away from the Sun. Next is Uranus, which is almost twice as far from the Sun as Saturn. It measures some 1,700 inches away. Neptune is another billion miles from the Sun. In our model, that puts it at 2,700 inches from the center of the solar system. Finally, Pluto is found at an average distance of 3,666 million miles from the Sun. Look where that places it in our scale model, all the way out here at 3,666 inches. What a huge orbit that is! As the planets orbit the Sun, they cover an enormous area during a year's time. If we want to include the nearest star to us other than our Sun, we would have to expand things even more. Using the same scale of 1 inch equals a million miles, the closest star would be a tremendous distance from this playing field. This field is near Chicago, Illinois. To include the nearest star in our scale model, we would place it nearly 400 miles away, here in Nashville, Tennessee. This is Proxima Centauri, and there is nothing between our solar system and this star. The solar system and universe are extremely immense. Traveling at thousands of miles per hour, it takes many years for space probes to visit the planets in the outer solar system. The outer planets are the four gas giants: Jupiter, Saturn, Uranus, and Neptune, plus the much smaller planet Pluto. These are different from the inner planets in many ways, in addition to their greater distance from the Sun. While the inner planets have solid rocky surfaces and dense cores of iron, these gas giants are made up mainly of hydrogen and helium. They have swirling atmospheres containing thick clouds of various colors. Pluto is the oddball of the solar system. Its solid structure makes it more closely related to the inner planets than the outer planets. Jupiter is the largest planet in our solar system, and it weighs twice as much as all the other planets combined. Jupiter is so big that 1,000 planets the size of Earth could fit inside. The planet's upper atmosphere is mostly hydrogen. Thousands of miles below this outer atmosphere, the pressure is so great the hydrogen gas turns to liquid. Scientists believe there may be a small core of rock and iron under this surface of liquid hydrogen. Jupiter gives off twice as much heat as it receives from the Sun. This heat is generated deep in the planet's interior. The clouds of Jupiter are unique and very colorful. The brightly colored bands are areas where warm gases rise to the top of Jupiter's clouds. The dark bands are areas where cooled gases sink back into the atmosphere. On the planet's surface, there is a huge storm that has been raging for over 300 years. It is called the Great Red Spot, and it is larger in diameter than 3 planets the size of Earth. Astronomers first observed it in 1665. The Voyager spacecraft provided us with lots of information about Jupiter, sending back many photographs and the exciting discovery of a ring system around this gas giant. Images sent back by the Galileo orbiter helped scientists determine that the ring system is made of dust from the small moons orbiting Jupiter. Comets and asteroids colliding with the moons caused this dust to be thrown into the planet's orbit. Jupiter has 63 known satellites, and scientists believe that there may be many more moons orbiting this giant. Io is one of the larger moons of Jupiter. It has the distinction of being the only known object in the solar system other than Earth to have active volcanoes. There may be as many as 300 volcanoes on Io. Jupiter's biggest moon, Ganymede, is the largest moon in the solar system. It is even larger than the planet Mercury. This moon is covered by ice. Callisto is Jupiter's second largest moon and ranks third in size in the solar system. Callisto is heavily cratered and is also covered by ice. Like Ganymede and Callisto, the moon Europa is encased in a thick layer of ice. It has no craters or mountains. Dark, jagged markings on its surface make Europa look like a cracked eggshell. The next gas giant is Saturn, and it is the second largest planet in our solar system. Saturn's ring systems are the most spectacular thing about the planet. The rings are made up of dust and ice. They start about 30,000 miles from Saturn's surface and extend about 170,000 miles into space. The particles in the ring systems range in size from a few inches to several feet in diameter. Saturn is the least dense of all the planets. In fact, it is less dense than water. If we had a tub large enough to hold the planet, it would even float. As of 2005, scientists have observed 33 moons orbiting Saturn. Beyond Saturn is Uranus. Uranus is twice as far from the Sun as Saturn. It has a very unusual tilt. Uranus is tilted 90 degrees on its axis, which means the north and south poles are pointed toward the Sun. Even though the poles point toward the Sun, the equatorial regions are even warmer than the polar regions. Scientists have no explanation for this phenomenon, but expect to one day have enough information to solve the mystery. It takes Uranus 84 Earth years to travel once around the Sun. During that time, one side of Uranus is in complete darkness for 42 years and in complete sunlight for 42 years. Like the other gas giants, Uranus has a ring system. The planet also has 27 moons. The farthest giant gas planet is Neptune. It is about the same size as Uranus and may have a rocky core surrounded by a surface of ice. Its thick atmosphere is made of hydrogen and helium with a little methane. Neptune also has a system of 4 rings. Scientists believe that Neptune's ring system is made up of water ice particles. The average temperature on Neptune is minus 200 degrees Celsius, or minus 328 degrees Fahrenheit. The winds of Neptune are the fastest in the solar system, reaching speeds of 2,000 kilometers, or just over 1,200 miles per hour. Pluto is the smallest and most distant planet. It is so far from the Sun that it takes 248 years to circle the star once. In 1930, scientists discovered that Pluto has a very strange orbit that at times takes it inside the orbit of Neptune. That means that sometimes Pluto is actually closer to the Sun than Neptune. Between 1979 and 1999, Neptune was the farthest planet from the Sun. Now Pluto has regained that distinction as its orbit has taken it beyond the orbit of Neptune. In 1978, a moon half the size of Pluto was discovered and named Charon. This image from the Hubble Space Telescope shows Pluto and Charon. Charon is unusual because it is so large compared to the planet it orbits. NASA has a mission planned called New Horizons, whose robot spacecraft will visit Pluto in 2015. It will take over 9 years to travel the great distance to Pluto. Because Pluto and Charon are so close in size, some astronomers consider them a double planet rather than a planet and moon. However, many scientists don't consider Pluto a planet at all. It has been suggested that if Pluto had been discovered today, it would not have been given planet status. Instead, it would have been considered a part of the Kuiper belt of rocky objects whose orbit intersects Pluto's. Despite the debate, there are no current plans to change Pluto's classification, so it will keep its status as a planet. Although Pluto is the farthest away of the outer planets, it is not at the edge of our solar system. In fact, it is not even close to the edge. If we were to travel at the speed of 35,000 miles per hour, it would take 10,000 years to reach the edge of our solar system. Extending beyond Pluto is the Kuiper belt of icy rocks. They are found in an orbit between 3 billion and 5 billion miles out from the Sun. There could be billions of these frozen rocky objects in this huge belt. Many of these pieces of space debris are of significant size. Some 35,000 of them are more than 60 miles in diameter. Some are close to the size of Pluto and have companion objects orbiting them. Beyond the Kuiper belt is the Oort cloud of dust and gases, which extends some 50,000 to 100,000 astronomical units into space. An astronomical unit is the average distance of the Earth from the Sun, or about 93 million miles. Scientists use the abbreviation AU when comparing the astronomical units of objects in our solar system. Jupiter is 5 AU from the Sun, and Pluto is 39 AU. So the Oort cloud is a tremendous distance from the Sun. Our entire solar system is surrounded by this huge cloud of dust, gases, and drifting comets. The Oort cloud represents the edge of our solar system. Sometimes comets stray out of their own orbit and travel within the orbits of the inner and outer planets. That's what happened in 1994 when the comet Shoemaker-Levy struck Jupiter. The comet had divided into about 20 pieces, and Jupiter's gravity pulled it into a collision course. When the comet pieces hit, the debris from the collision was visible for almost a year afterward. As comets travel near the Sun, radiation from the solar wind causes the ice to form a cloud. The cloud spreads out in a long tail that is always pointed away from the Sun. This gives the comet the appearance of a definite head and tail. In 2005, NASA successfully crashed a space probe into the comet Tempel 1 in an attempt to view its core. The energy of the crash was equivalent to exploding 5 tons of dynamite. It created a large crater that enabled astronomers around the world to take pictures of the interior of the comet. Because it is believed that comets are made of the same materials used to form the Sun and planets of our solar system, scientists would like to discover as much as possible about their makeup. One problem is that comets are so far away that they take hundreds and sometimes thousands of years to enter our neighborhood. As you can see, when dealing with space, even our own solar system is so huge that we will never travel to its edge. In addition, there is still much to be discovered about the objects that share this expanse with us. All of the information we have about other planets comes to us through the use of space probes, telescopes, and other sensing devices. Scientists depend on their ability to send robotic probes into space to gather information, collect samples, and take pictures. Data collected by these probes is easily retrieved by receiving antennas on Earth, allowing scientists to study it for analysis and interpretation. Space exploration demands tremendous organization and precision, as in the landing of a rover on the surface of another planet. Here is the sequence of events required to safely set this expensive and delicate piece of equipment on the surface of Mars. The Mars rovers were launched into Earth orbit by a 3-stage Delta II rocket using a main engine and additional solid fuel engines. As their fuel was used up, the extra engines fell away. When the main engine's fuel was depleted, it too was discarded. Then the nose cone was cast aside. Small jets were used to spin the spacecraft and maintain a straight trajectory. This is a bit like a football quarterback throwing a spiraling pass to help the ball fly straight. The rocket's third stage blasted the craft out of Earth orbit toward Mars. Since there are no gases in space to create friction, the spacecraft continued at the speed established by its third stage. 7 months later, the craft arrived at Mars. When it entered Mars's atmosphere at a speed of 12,000 miles per hour, the resulting friction built up tremendous heat. The temperature on the underside of the craft rose to 1,600 degrees Celsius. The craft's heat shield prevented it from being burned up. Its parachute slowed the lander's descent, and the heat shield was discarded. Cushioning airbags inflated to protect the delicate cargo. Because the Martian atmosphere is much thinner than ours, a parachute alone isn't enough to achieve a safe landing speed. Retro rockets further slowed the descent, and the cushioned lander bounced its way across the planet's surface. When it came to a stop, the lander's airbags deflated and it turned itself right side up. Then its shell opened to reveal the rover inside. The rover unfolded its solar cell panels to collect sunlight and help run its electronic components. Although no humans have ever visited another planet, astronauts have traveled to our moon. Because the sun releases many forms of radiation that are extremely dangerous to humans, astronauts and cosmonauts wear suits with many layers of protective insulation. They must also bring their own oxygen, air pressure, and food. Space travel can be very difficult, and it's crucial for astronauts to be well prepared. The new technologies developed to protect astronauts on their voyages often result in products that benefit those of us who will never set foot in space. The advantages of sending astronauts on these exploratory missions are well worth the preparation and precautions. An astronaut's human eye and judgment far outweigh that of any mechanical tools in collecting samples or setting up experiments on a distant world. In 2004, President Bush announced a new vision for space exploration. He committed the United States to manned space trips to the moon and eventually to Mars. He directed NASA to finish the International Space Station and to build a new crew exploration vehicle for use in exploring beyond our orbit to other worlds. Our fascination with the unknown keeps us searching for answers to questions about our planet and our neighbors in the solar system. And we have attempted to venture beyond those boundaries, out into the rest of the universe. It took years for the Voyager spacecrafts to reach the outer planets, and they continue to fly away, deeper and deeper into the vastness of space. On board each spacecraft is a plaque with a map showing how to get to our planet. Each craft also carries a gold-plated record containing messages in every world language and an assortment of sounds from the animals of Earth. The Voyagers will continue to fly through space for many years to come. And, just maybe, they will guide other explorers to us.